Okay, hello grade 11s. I'm just going to take you through an example of solving a right triangle, and I have a second video of another example. In this example, I start with an angle, and I also have the length of one side. Again, this is a 90-degree right triangle, so all the triangles so far in this unit are right triangles, but on Monday we're going to start looking at triangles that do not have right angles. So the first thing that we're going to do here is we're going to find out what information we can easily get from this triangle. And basically what we'll find is that we can quite quickly find our third angle. We know that all the angles in a triangle always add up to 180 degrees. We have one angle that's 90, one angle that's 48. So with a very quick calculation, and again, the format that I'm going to use here is the format that I would like to see you use as well. So angle, that's an angle symbol, so angle T equals 180 minus 48 minus 90, and that equals, well, 180 minus 90 leaves us with 90. 90 minus 48 leaves us with 42. So that means that angle T is 42 degrees. And if this question seems familiar to some of you, a few of you have already worked through this sheet, and this is the practice sheet from the other day, so you can check your answers as well. Okay, so at this point I have two angles and I have one side. So what I'm going to have to do from here is to find the length of another side. And what's happened now is because I have multiple angles, I can use a few different methods to get this. Let's say, for example, that I made this my reference angle. Well, if I made angle U my reference angle, the angle that I have is the opposite. Okay? I would then be looking for either the adjacent or I would be looking for the hypotenuse. So let's say that first I want to find side T. And again, if this is the angle that I've decided to use, this would be my adjacent side. Side V is across from angle V, and this would be my hypotenuse. So let's say first I want to solve for angle T. I know the opposite side. So again, this is the opposite. So if I wanted to solve for side T using 48 degrees as the angle, I'm looking at the opposite, and I'm looking at the adjacent. O and A go with TOA, so we know that we're going to do tan of 48 degrees is equal to the opposite, because we're talking about tan, and we divide that by the adjacent, which in this case is T. Now, in order for me to actually solve this, I have to go ahead and cross multiply, and again, I've explained this in class a few times, and basically what we found in the end is the shortcut is that I can just switch tan 48 and T. Again, the reason that works is to get the T out from the bottom because we don't want it underneath. We multiply by T on both sides. The T's cancel out on this side, and we have a T over here on the left. We then divide by tan 48, so the tan 48 comes up underneath. So what we're going to have here is that T is equal to 12.1 divided by tan 48. And then if we go ahead and calculate that, we get that T is equal to 10.9 meters. Okay, so that's side T, and then we'll take a look and we'll see if that makes sense. So this angle is bigger than 42, and it makes sense to me that the side across from it should be bigger than the side across from here. We also know that this last side we're going to find, the hypotenuse, is going to be the longest side no matter what. So if we find out that it's not, that means that we have done something wrong. So let's go ahead here and we'll sort of section this off. Now I have this side, I have this angle, I was given this, I was given that. That's a 90-degree angle. So the only thing that's left is for me to solve for this side here. Now, a lot of you are going to want to do the Pythagorean theorem, which is great. If you were going to do that, you would have v squared is equal to u squared plus t squared, and you'd use the value that we just found. The nice thing about trig now, and kind of also one of the things that makes it a bit tricky, is that we have several options of how to find the hypotenuse at this point. So let's say we're going to use 42 degrees as our reference angle. Well, now we're interested in the hypotenuse, and we can use either the opposite side. So this will now be the opposite side if we're talking about 42 degrees. And then we could use the hypotenuse. So we could use sine of 42, or to find the hypotenuse, we could use this angle, and we could use this side, which would be adjacent to the 42 degree angle, and we would use cos. Or we can come back up here, we can use the 48 degree angle. We're still looking for the hypotenuse. So if we use this side to help us, that would be the opposite, and we would use sine. Or we now know t, it's 10.9, we just found it, so we could use the adjacent to find the hypotenuse, and that would be cos. So again, there are several options. So what I'm going to do is I'm just going to use the 48 degree angle again, and I'm going to use 12.1 meters again. The reason I'm going to do this is because if I made a mistake in this calculation to find 42 degrees and then used it, my answer for the hypotenuse would be wrong. Also, if I made a mistake in here finding t, and often we make mistakes cross multiplying, that when I then found t, it would be wrong. So if I use t to find v, my answer would be wrong again. So what I'm going to do is I'm going to use the 48 degree angle as my reference angle, just like I did last time. So I'm looking for the hypotenuse. I still have the side opposite of the 48 degree angle, which means I'm dealing with O and H. And SOHCAHTOA tells us that the letter that fits in here is S. So I'm using sine of my angle. Remember, sine is always sine of something. It's not just sine. So sine of 48 degrees is equal to the length of the opposite side. So O, which is 12.1, divided by the hypotenuse, which in this case is V. And just like last time, my variable is on the bottom, so I have to switch these, and I end up with V equals 12.1 divided by sine 48. And so V equals 16.3 meters. And again, I'm going to double check to make sure that that answer makes sense. I know that V was the hypotenuse, so it should be longer than the other two. 16.3 is bigger than 12.1. 16.3 is also bigger than 10.9, so my answer makes sense, and I have solved this triangle. Okay, so that's how you do one of these from start to finish if you're given a side and an angle.